Hello everyone, we will begin our discussion today with 12.5, simplifying complex fractions. So what will we do with some complex fractions is we will simplify a complex fraction by simplifying the numerator and denominator, that's step one, and then dividing it using, of course, our dividing procedures. We will simplify a complex fraction by multiplying by its LCM of all denominators and then simplifying. So let's look at a few models reflecting on complex fractions. So here are the procedures we will begin. Step one, simplify the numerator. So it is a single rational expression. One, simplify the denominator. So it is a single rational expression. Then at last step, we will divide the numerator by its denominator and reduce the fraction to its lowest terms. So these are the procedures that we will practice and get familiar with. Okay, example A, 2x over y cubed divide 5x squared over 6y to the fourth. So what needs to occur here is that we realize with step one, we have that single numerator, denominator. So we know that is already expressed. We then have our bottom fraction, complex fraction, with single denominator. So what will happen is that we can just separate. We will separate by simply saying 2x over y cubed, and then separate here by saying divides 5x squared over 6y to the fourth. So right away with dividing, remember we must apply keep, change, and flip. So in that procedure base, we're now dividing. We will keep 2x over y cubed. We will keep that fraction as stated. We will then change division to multiplication, and the flip will now occur with the division of fraction. So that simply means x squared will now move to the denominator, 6y to the fourth will now move to the numerator. So let's do that flip. 6y to the fourth over 5x squared. And then our last step is where we're looking at simplifying. And so here, when we look at simplifying, hopefully we are able to see right off the bat that we can simplify beginning with the x and x squared, which will leave me having an x left here. And next we will take y cubed and y fourth, and that leaves us with 1y in the numerator. So what do I show here in the denominator is 5 left, and what's left is an x, okay, that's in the denominator. And what I show here in the numerator, 2 times 6, and what's left is a y from the y to the fourth. So that leaves me with 2 times 6 for 12, y over 5x, final answer. Okay, next, 3 plus 4 over x over 1 minus 5 over x squared. Now, in this model, we have to we could get one simply fraction. So what needs to occur here is I need to work on the LCD for the numerator and then the LCD for the denominator. So by me placing 3 over 1 here and 1 in x, of course, I see that I can have x as my denominator in my top complex fraction. So of course I realize that what's missing from my denominator is x. So now I will show 3 times x, and that will turn into 3x. And then, of course, we have x in the second fraction, which will basically remain 4 over x. All right, so I now have one fraction, which is 3x plus 4 over x. Hey, we're just gonna. So we're left with 3x plus 4 over x as the top fraction. Now let's resolve the second fraction, which is in the denominator. So 1, we will allow 1, of course, to make that simply become 1 over 1, which we see that the denominator would be x squared minus x squared. And so once again, we're able to see that I multiply this by x squared to get my denominator x squared. So the top will multiply it by the same x squared. And there I get x squared minus, and that checks out to have the same denominator. So we have minus 5. So this complex fraction will be x squared minus 5 over x squared. Okay. So now I have my single fractions, and we can now show the 3x plus 4 over x divides x squared minus 5 over x squared. And we're at the division step where we will now apply keep, change, and flip. Once again, what will I keep? I will keep 3x plus 4 over x. What will I change? Change division to multiplication. And what will I flip? X squared, the denominator, will now turn into the numerator. X squared minus 5 will now become at the denominator. And so I look, can I cross cancel anywhere? And hopefully we can identify that the x will cross out with x squared, which leaves me with x. So there I simply have x left times 3x plus 4 over x squared minus 5. So to simplify this, we can do simplify here, or we can distribute the x through as well and have the final answer as x times 3x for 3x squared, 4 times x for 4x over x squared minus 5. So either answer is correct. Okay. So this will be part 1 of complex fraction. I do have 2 more models that I will demonstrate on the second video. So let's just call this part 1. All right, and then follow will be part 2. Okay, thanks.